All right. Welcome back. Hope you guys have enjoyed lunch. I have 15 minutes to talk about a particular testing framework, which is called a Spock. So let's see some hands before. Who has used a Spock already? Only a few hands. Okay, so perfect. You're in the right place to learn about this thing. This is the only slide I have about myself. This is the boring stuff. I'm a Java developer. I'm also a member of the Groovy development team, which is how I eventually found Spock. Now, some facts about Spock. Okay. Oh, it's almost running out of battery. So that is the website. What is a Spock? Spock is mostly testing language. Some people call it a DSL, some people call it a framework, but the author, Peter Niedewisse from Austria, that is his Twitter handle, calls it a testing language. So that puts you in a different mood when you're writing a test. It is Groovy based, so please don't get out of the room. Groovy is very interesting, and I'm going to show you some of the things that you can do with this thing. It does. When you compile a Spock test, it actually rearranges the bytecode in such a way that it makes sense. Because what you write in the test is not exactly per se standard Groovy code. I'm going to show you an example of what I mean by this. So let's go directly into it. There's perfect support for Spock in IDEs and CI servers. So if you already know how to run JUnit tests and TestNG, just migrating to Spock is as easy as just putting a new dependency, and that's it. So let's see a first cut of a Hello World specification in a Spock. Because this is Groovy, there is less visual clutter. So long gone are the semicolons and public modifiers and all that. Let me tell you that even though this is Groovy, you can test Java code or even other JVM languages, even Scala. So here, we extend from a specific class, which is a specification, and the next thing that you see is the method name. Is there something weird about that particular method name? It's a string. How cool is that? Means that you are no longer constrained to use a camel case convention on the method name. You can just expand yourself writing what is the real intent of this method. And because Groovy even supports multi-line strings, you can put multi-line strings as the method name. Okay, but then we see two blocks of code. One when we see the expectations, and the other when we see something that looks like a table. And this is what I meant about that the code looks like Groovy, but it's not real Groovy code. Because if I were to compile this through the Groovy compiler, it will just simply break. You will see a compilation exception. But the Spock compiler, which hooks into the Groovy one, will make this thing wrong. So what we're seeing here is actually 3 different test cases in just one definition. During the invocation of the spec block, it will be run as many times as we have rows in that data table. So what you're seeing here is your first cut at a data-driven test case. I know you can do these things with JUnit and TestNG. You have to annotate a method with test data or some other annotation and provide an object array with all the different values. Well, I will say personally that this is much better because the information is right there. Also notice that what appears to be table columns, those are actually the variable names. Then, is everybody okay with this? Okay? So far, so good? Okay, so this works. Let's see what happens when we introduce a bug in our test case. Come on, work. Okay, let's do it this way. Yeah, somebody paid attention during Niels' first keynote. So I just made this a small change. And of course, the length of a Scott is no longer, it's not 7, it's 6. So when I run this test case again, this is the output I get. If you have seen this before in Groovy, these are the power asserts. So what we're seeing is pretty much a graphical representation of the values at the time that the assertion took place. Now we know, of course, that name points to a Scotty for that particular row iteration, and the size of that is 6. Then the length variable it's 7. But the comparison turned out to be false. This is why we're failing. Now, as you continue with your test cases, the asserts, whenever they fail, they will use the two-string implementation for your objects. So for the name is just a string, so it simply prints it out. So if you eventually encounter one of these outputs that is not very descriptive, then just make sure that you have a proper two-string implementation on the said object, and then you'll see much better things. Okay, so that was the first approach at Spock. Let's see some of the feature list. I mentioned 2 blocks only at the beginning, expect and where. But there are actually more blocks. We can write specifications in a behavior-driven development way. If we start with the given block, where we define what is the initial state of the things that we're going to test, then we define when block. This is when we exercise these objects. And finally, we can have the spec block, where implicitly every sentence, every statement that you put has an assertion. If I go back 2 slides, here where it's clearer, you see that inside the spec block, there is no assert something. There is no assert equals as we find in JUnit or TestNG. That is because Spock knows that within this block, everything should be using an implicit assertion. So let's go back to the blocks. The others, and is mostly an alias for the current block that was previously. So you can put given, and, when, and, then, and finally, an expect one. And finally, cleanup. Whenever you want to execute some code at the end of the feature method, we call these test methods feature methods. Whenever you want something to be executed just at the end, then make sure that you put a cleanup block, and that's it. This will be akin to having tear down method in JUnit. We also have life cycle methods. Similar to setup and tear down in JUnit, you can put setup or cleanup methods in your expectations. This will be called at the beginning and at the end of every single feature method. But if you need to do some setup for every method, so at the class level, you know that in JUnit you have before class and after class. Well, in a Spock, we have setup spec and cleanup spec. It's pretty much the same thing, but without the annotations. I show also a little bit about the data-driven, just using the table. There is another syntax if you do not like tables, which is the list-based syntax. I don't think I have an example for this. But then you can see 2 other annotations. This I like very much. On-row will make sure that the method that you're writing that depends on different rows in a data will have a specific entry in the ID when you run it, or it will have a specific entry in the report. If I run this example without the on-roll annotation, the report in the output will say, you just ran 1 test. But we see there are actually 3 different tests in here. If I apply the on-roll on it, then both the JUnit report and the IDE window will have different rows, each one of them depending on the rows on the data. But notice again also on the method name, now I have changed a few things. And I have something that looks like variables using the hash or pan or octosharp, depending on how you want to call this thing. These are actually placeholders for the values that you have in each one of the rows. So when I run this code now with just these little variations, applying on roll and changing the method name, if I run this in IntelliJ IDEA, if it's correct, notice now the method names. Now we have 3 different method names, and they have the right values, depending on each one of the iterations. And if I make the same mistake as before, introducing a bug, then just one of them fail. This is really nice. Let me show you live. Let's go into IntelliJ IDEA. Go into IntelliJ IDEA. And let's take out on roll. Let's go and run it. There's only one method. But if I do it this way, then there are three methods. What happens if I introduce the bug here? Well, I will see only one failure being reported. But I don't know which iteration made it fail. Of course, when I see the output here in the power asserts, oh, it's the last one. Okay. So if I activate back again unroll and run it once more, then I see that the first two are actually green and the third one is the one that failed. This is much better. This is much better. All right. Yeah, the clicker is dead now. There are other features that Spock has, and this is what we call interactions. In other frameworks, they are called mocks. What we're doing here is make sure that in this particular model class, which is an observable class, it uses property chain listeners to trigger property chain events whenever a property changes value. Well, that was a mouthful. So we mock out a property chain listener. All right? Notice that we use given block. We're setting up our environment. Then during the when block, we execute these things. We add the listener to the model, then change the property twice. The listener should have been notified twice. That's exactly what we're going to assert during the spec block. But what is that? We're saying one times listener property change and then something inside as an argument. That something is a Groovy closure. What we're saying here is, I expect that the property chain method on the listener mock is going to be called once, and the argument could be anything. If I want it to be a full wildcard, then use an underscore like in Scala. Or I want to assert that whatever was passed in as an argument, it should have a property or a getter that reacts to a new value, and that value should be equal to Groovy. And then I do the same thing for Java. And it works. You can, as I mentioned something about the wildcards, if I have many mocks, I could go as crazy as saying, instead of listener, just an underscore, so any mocks that I have, or just underscore on instead of property change, so any method. I can even use regular expressions on the method names, if needed be. There are definitely more features that I can show you about Spock, but I only have a few minutes left. But recently, the team published a brand new documentation site, and that is the homepage where you can find it. It's pretty good, it's pretty nifty, and it contains pretty much everything that you need to get started with Spock. Spock is also extensible via plugins. There are a handful of plugins already out there, particularly for reporting. You can also do functional web testing with another project called Jeff. And for that, there are plugins for both Grails and Griffon. And the next release, the current one is 07. The next release will happen sometime next year, probably sooner than we expect, will be finally 1.0. So Spock is definitely enterprise ready if you want to use it right now, but just some minor things that they need to fix up with the documentation. But yeah, just use it, just test it. With that, I think that I have 2 more minutes in case that you have any questions, so you want to see more examples. No? Yes? If you want to use it in a Java project. You can, yes, Spock is available from the Maven Central repository, so you can configure it using Maven or Gradle or any other build tool that you have at your disposal. And as I said, you write the test in Groovy, but you can use it to test a Java-based project. Right? Well, thank you very much for your attention. I have one final announcement to make. I'll be signing copies of the Griffon in Action book right after this session downstairs on the library in case you're interested. So again, thank you very much and continue enjoying this great conference.